I'm Kevin Milliman. I'm with the DCP Midstream company. We are the data sponsors for the Pi World Conference. So DCP 2.0 is a digital transformation initiative that we are undertaking as a company. What that means is how do we use our data better, information better, to be more to meet our business objectives. We want to be the lowest cost, safest natural gas midstream company, and this is a method of us reaching those business goals. Where we are now is we have about a year of this Pi system and digital transformation underneath our belt, and we are looking now to take the next steps. Digital transformation is critical in all. I mean, we can see it throughout our economy. It hasn't reached the midstream sector yet, but it will. We all understand the capabilities and the use of information by companies has transformed businesses across the spectrum, and we want to be at the leading edge of that transformation within the midstream and oil and gas sector. I think I mentioned before, but our unique challenges are we're very capital intensive. We work in a commodity market where pricing is hugely important, value to the customer is hugely important, and we are geographically dispersed. We have gas processing plants, which are relatively large facilities that are centrally located. However, we have a whole set of pipelines and booster stations that connect those gas plants both to the wellhead on the producer side and then to the retail markets, either whether they be pipelines or fractionation complexes in the various parts of our country. Where we see the opportunity for digital transformation is to allow us to run these assets more efficiently. How will we drive cost out of the business? How do we capture more value for ourselves and our customer by running our facilities more efficiently and more effectively? And that's kind of some of the use cases that we want to explore during this hackathon. What's unique to me about the midstream business is usually think about selling products into a market, and that's what we do. We sell our processed gas into the market, we sell our fractionated product into the market. However, our feedstock is the people who provide us the gas that we process. We also view as our customer, because if we don't have the producer's gas to process, we are not going to make any money. So the efficiency of our operation affects the people who provide us the gas, our primary customer, as well as they can affect the downstream markets to which we market. So if the gas isn't flowing from the producer's well, the producer suffers. If we've committed to delivering that gas to the pipeline could suffer, and certainly it's going to cost us money on both sides of that value chain. When you look at the use cases, we have a number of items or a couple of business opportunities centered around compressors. As you know, why are compressors so important? The only way gas moves is flowing from a high pressure to a low pressure. And when you look at the wellhead, the producers want the gas at their well to be as low pressure as possible. When we go to process that gas, we have to raise the pressure up to nominally 1,000 psi. To do that, we need compressor stations. We need lots of compressor stations to feed one plant, and that's just the nature of oil and gas wells, is they are small amounts of oil, relatively small amounts of oil and gas spread around a large geographic area. So the boosters, what we call boosters or compressor stations out in the field, will collect gas from a number of different wells, boost it up to a pressure to allow that gas to flow to our processing plants. Compressor stations are very expensive pieces of capital, and to run them it requires thousands of horsepower per station. These are big engines. These are not your Briggs & Stratton lawnmower engines. And obvious, as you might expect, we want that capital to be put to work, and we want it to be as full as possible. We want it to run as efficiently as possible. Just like your car, you want, all things equal, you want to put less gas in there than more gas. You want your compressors to provide you the best power, the most gas, for the least amount of fuel that you put into them. And again, the capital efficiency aspect of keeping our boosters full is extremely valuable to us from a business standpoint, as well as the overall energy efficiency, fuel efficiency, how we put that that energy to work moving gas is very important to us. Unplanned outages hurt us in a lot of ways. So there's the obvious impact of gas that we were going to process, we can't process. There are customer relation issues that can come into effect. If a customer is expecting gas to be flowing from his well and it stops flowing, then he's not making money on his gas and oil that well would have produced. On top of that, there's the response to an unplanned outage. That could range from something relatively simple, like we have to restart a compressor engine, to something more complicated and impactful, such as we have to reroute gas from flowing to one compressor station to another compressor station to allow gas to continue to flow. And it could entail more challenging and expensive efforts to fix the problem. Why did the compressor go down? If something broke unexpectedly, now you have all the complexities associated with fixing a piece of equipment that you were not planning to fix. Do you have the right parts? Do you have the right people? And then the logistical aspects of rerouting gas, notifying customers and other stakeholders that could be associated with a significant outage. It can range from something simple like the unit tripped on some high pressure signal and we just need to go out and restart it. Could be something like we had a bad valve, we got to go out and do a valve swap, which might be a shorter period of time, maybe a few hours, to we broke a crankshaft, it's going to be a 3-week delivery on a new crankshaft or longer, and our operations are impacted that entire time. And again, because we are part of a continuous flowing process from the wellhead to the retail markets, anybody along that value chain can see and does see impacts depending on the nature of the incident. Just from a very global scale, we want to remove unplanned downtime. We want to also move from a state of where we are, where we either do maintenance, routine maintenance on equipment, either by calendar, in other words, every 3 months go out and perform this preventive maintenance task, or we currently do it also on run hours. So change the engine oil every 3,000 miles. Not 3,000 miles, but so many run hours. Same idea. What we want to get to, we want to evolve to, is where we only go out and fix things that need to be fixed when they need to be fixed. And ideally that would be before they fail. So what we want to do is we want to get into a maintenance cycle where we are doing condition-based maintenance. What that does is that should allow us to extend the periods of time between major maintenance events, and it will therefore reduce the amount of time that we spend doing maintenance. It can cut down on the miles that we travel to and from sites, which I think I gave you a statistic earlier, 43 million miles per year traveled. If we can shave 1% off of that, think about that. That's 400,000 fewer miles. Just on the fuel alone, you can do the math. That's significant savings. From a unplanned outage standpoint, as I said before, we really want to avoid those completely. So how do we do that? We have to be smart enough to know when our equipment needs attention, and we have to be smart enough to be able to respond quickly and when those needs are identified. Contrast that with how we do maintenance today, and how we take care of our equipment today. So right now, I think I mentioned before, we have, call it, 3 major sources of information on maintenance. One is we have an operator or a mechanic will go to most compressor stations on some periodic basis. Could be daily, could be longer periods, it could be every couple days, every 3 days. When they're out at the site, they'll go ahead and collect information about how the equipment's running. They'll look at oil levels. They monitor the equipment to make sure it's performing well as perform routine tasks. Another source of information is through our SCADA system. We have a series of sensors that are deployed at our stations that monitor our equipment. There's variability in terms of the level of instrumentation we have at each facility. So we have a greater or lesser visibility to units, compressor unit health at various stations. But we can take that information and use what we have to be able to take care of the equipment today. In some cases, there's very little information, as little as the engine's on or the engine's off. In other cases, we have highly instrumented pieces of equipment where we have a lot of data that can give us insight into the engine health or engine and compressor health. The third stream of information is we have more detailed equipment health checks that are performed by our equipment analysts on a periodic basis. Again, it varies by unit, but typically once a quarter they'll go out and collect a lot more detailed information about the performance of the compressors and the engine, which we will use to guide both maintenance activities as well as operational tuning, if you will, of those compressors. That's, again, on a periodic basis, nominally once a quarter. That's today's standpoint. What we want to see in the future is we want to know how that equipment's performing real time, every day, and we want to know not only is it on, is it reaching the discharge pressures we want, but we want to know, is it close? Are there any indications that we are getting close to a failure event? Are we experiencing a processing issue that perhaps we could address, if not necessarily just from equipment health, but maybe there's process equipment. So an example would be weather. Weather can cause us problems with freezing of gas in the line. That's can be a real challenging issue at certain times of the year. We should be able to understand and be more targeted in which instrumentation we're looking to add based on an analysis of the data that we have today. Right now, I think as somebody once said, as an engineer, instrument the heck out of everything. The reality is all that costs money, it costs upkeep, so we want to get a little smarter about instrumentation. And where we might want to add it. Very interested in seeing what the machine learning guys can come up with based on analysis of our existing information. Currently, if we have an issue with a compressor station or some other interruption which causes to have to reroute gas, those decisions are made in the field, and they're often with limited information. Limited information in the sense of the people in the field know their systems. They know where the pipes run, they know where the valves are available to them to move gas from one place to the other. They understand how the systems respond. They have a good sense for how much gas can flow to certain areas. However, there's a lot more complexity involved that we don't always systematically address. And so, for example, we don't always know which plant is preferential if we have the ability to route between two different processing facilities. There could be constraints, and there are constraints at certain plants. Certain plants cannot take gas with H2S in it. Other plants are designed and they have to have a minimum amount of H2S flowing to them in order for the plant to function correctly. So what can be very helpful for us is if we have a system which allows us to understand our routing options and understand to some degree what our constraints as well as what our opportunity, our maximum opportunity, however that's defined, whether that be purely financial, whether that be some other metric. We want to be able to use our data to make those decisions, which right now are made based on relatively limited data, based on call them expert knowledge, for lack of a better term, and are often based on experience. We want to capture and build on that knowledge and experience and supplement it and augment it by using more rigorous data that's coming from our field and our compressor stations and our plants. Local site knowledge of the gathering system, which is essentially the pipes from the wellhead to the compressor stations and from the compressor stations to the processing plants, is extremely important, particularly in our company today. There's a lot of tribal knowledge right now that we are working with and we rely upon for our operations. It's very effective. It can be very effective. However, it's also a potential weakness. If somebody retires, if somebody moves to another company, we lose that tribal knowledge. So one of the things we want to achieve is a more consistent and standardized way of looking at our systems and our operations, and we want to have it become more real-time data-driven, and data-driven in such a way that it's repeatable. We don't want it to be Joe learned some unique how to operate our system efficiently based on his experience, based on data from his experience, but then that data gets lost. We want to encapsulate and learn the knowledge and become better over time based on better use of our information, better capture of our information, better analysis of our information. When we look at our where we were about a year and a half ago, we had our data was very siloed. We had data available through our SCADA system, real-time operating data available through our SCADA system. It was generally available, but it was not widely available to everybody. In some cases, some of our control systems at plants and boosters, we had no visibility to the data unless you had special permissions and you had a special piece of software, and in which case you could run special queries, pull that data out, which was very cumbersome. Where we are today is light years ahead of where we started a year and a half ago. The visibility of data is unprecedented. Operational data in particular is unprecedented from our company's perspective. Using the tools already at our disposal, we're able to see data from essentially all of our plants, all of our 500 booster stations with the click of a button. It's very available to people, and we're continuing to build this out. Where I look at this is we are just at the very early stages. We are making the data from our operations visible. We are capturing value just by having that data visible. Where we want to go is that next layer. Okay, we can see the data, we can see real time what the temperatures, pressures, flows are. Now we want to get a little more sophisticated. How do we use that information and help it optimize where is the best way to route our gas? Do we fill up a pipeline to its maximum capacity so we can shut down another one? Do we reroute gas from one compressor station to another so we can shut down an engine at one? Those sorts of questions will only be answered by a more rigorous examination of our data, and then to be able to take action quickly. We can't have it be a very complex relationship where we send somebody off in a corner, do this complex analysis, come back in a week, here's the answer. What we want is the people that need to make decisions, that can make decisions, to have the information at their disposal immediately. When our system optimizer is either given an opportunity, a change in the market, we want them to immediately understand what moves they can make and what the value of those moves will be, so we can take action in the field to change gas routing, as an example. One area certainly where data visualization may have or we expect to have a tremendous impact is at the people in the field. And what that means is I would expect them to say they need real-time, accurate information wherever they are. And they are in their trucks, and sometimes they're at booster stations, sometimes they're at plants. A lot of times they're somewhere in between. They could be out near a valve set on a pipeline in a field. They could be out at a meter station far away from either a booster station or a plant. Or they could be located inside of an operating plant facility, and they want to understand not only what's happening at their plant, but what's happening in the gathering system that's feeding their plant. What's happening on the downstream side of their plants. What do they have visibility to pipeline information? Those are areas of opportunity for us to get more of this data, make it more visible to those people who then are closer to the point where action needs to be taken. At the other end of the spectrum, management, again, peeling the onion. They have the first set of metrics and data. They've had data before we embarked on this digital transformation. However, the richness and completeness of the data that they're getting now is much greater. So they have, and it's the first layer of the onion. They have the fundamentals. They have how much gas are we flowing, how much did we think we plan to have flowing, and what are our products that are coming out of the gas that's feeding our plant. What we expect is the management team will want to have the next level of detail for the information. How are we performing overall as an asset, from a financial perspective, from a operational perspective? What's our capability? That's the one that I'm really interested in. So when you look at gas, right? So one thing is, you're moving gas through your system, and you can say my compressor is running as efficiently as possible, my pipes are not overloaded, my plants are processing all the gas they're receiving. What we really want to get to is what gas is available out in the field that if we changed our operation we could collect more of. Are there changes that we can make in our operation to draw more gas to us? That helps us. We process more gas with the same amount of facilities, but it also helps, typically it will help our customers. Typically by processing more of their gas, not only do they get the revenue that the sale of that gas, processed gas, provides, but sometimes it helps them operate their facilities more efficiently so they can actually recover more. Today, what DCP does is we do share volume pressure data with customers. We share volume data at different levels of aggregation and at well by well gas flow data on a periodic basis. We can provide that data more real time, and ultimately what I would hope is, what I would expect we want to do is we want to integrate ourselves more deeply with our producers. Imagine a scene where instead of, okay, I own the well, my process ends at the wellhead, and at that point you have a certain flow rate and pressure. Imagine now if we had one continuous integrated stream where we could see all the way back into the well and and what the producer is seeing all the way into what's happening on the pipelines. Basically, today's standpoint is we offer data. It's typically not real time. We do have some cases where we can offer real-time data snapshots, but it's limited. What we operate is a network of facilities. We are in the middle of the network. It would be very helpful to know, and it would be very valuable for our customers to know how that network is performing as a whole, rather than, I don't know how much electricity you're going to send me, but I've got this network of wires. I want those wires to carry all that electricity to its end user, but I'm not going to tell you what you're going to make. Or conversely, I'm generating all this power. I don't know what my network is doing, but I'm going to keep generating that power until that network can't receive that power anymore. Then I need to make adjustments. The thing that's valuable is, how do we unlock the potential of our facilities? These are very expensive pieces of equipment we have sitting out in the field. They are running today. If we can squeeze out a little more efficiency from them, tremendous value to us and value to our customers. If we can process more gas from those same facilities, all the better, right? We gained on capital efficiency. Those are the opportunities we want to start unlocking. How do we do that? One way is find out what sort of events we might be experiencing, and recognize the telltale signs so we can take action before the event occurs. That's one of our business cases. And another business case is, how do we take these big pieces of expensive equipment that we own and operate, and how do we avoid having to shut them down even for planned maintenance, except when it's absolutely necessary? How do we avoid having to travel out to a remote site except when it's necessary? Those are the overall business objectives we want. We do that. We've tapped into a huge amount of value that we're not fully capturing today. And that's not just for us, but it's for our customers, because ultimately we win when our customers win. That's the only way it works.